All right, guys, lastly, we're going to solve equations with logarithms, okay? So, for example, if we have an equation such as 10 to the x minus 1 equals 25. Now, I don't know what power of 10 would equal 25. There isn't really one. I have 10 and 100. So what we can do is we can take and we can rewrite this in logarithmic form. So because this is a base 10, this would be log base 10 of the answer, which is 25, and this is going to equal the exponent x minus 1. Now, how does this help me? Well, because I can actually find log base 10 of 25, which is the common log, so I really shouldn't put a base 10 there. I should just put log of 25. I can use my calculator to find that. Now, before I actually use my calculator, however, I'm going to finish solving for x. So this log of 25, we're going to add 1 to it because to solve for x, we have to add 1 to both sides. So we're going to add 1 to this side. Now, notice here I'm being careful to put parentheses. That's because the log of 25, that is one piece. That's one number. Okay, I'm going to find that number, and then whatever that number is, I'm going to add 1 to it. However, the exact answer for this would be 1 plus log of 25. And this is the reason a lot of times you'll see constants added to the front instead of the back, so there isn't any confusion. But if I want the approximate answer, I'm going to go to my calculator, and I'm going to type in log of 25. We have to close out the parentheses if we're going to add 1 to it. Okay, so the calculator will know what to do as long as you put the parentheses. Watch what happens if I don't put the parentheses. I get a completely different answer. That's because it's doing the log of 26. So either you have to put the parentheses or you have to do it separately. Log of 25 and then add 1 to that answer to make sure it's correct. So 2.3979 blah blah blah. So they told us here to round to the nearest thousandth. So that's 3 decimal places, so 2.398. 2.398 is the approximate answer for x. Again, if we want the exact answer, we write it with the logarithm. The approximate would be a decimal. Okay, so since it said approximate, we're doing approximate. Now let's look at another one, number 18. The natural log of 2x plus 3 equals 4. Now, I can't type in the natural log of a variable. It doesn't work that way. I can only take logs of numbers. So I could take log of 25. I could take the natural log of a number, but I can't take the natural log of 2x plus 3. So instead, what I'm going to do is, again, change this into a different form. Let's see if exponential form is more helpful. So the base of natural log is e. The exponent is 4. And this is going to equal the answer 2x plus 3. Now, this is a more helpful form because e to the 4th is just a number. I can find that value. But again, I'm going to keep this precise for as long as I can. I'm going to solve for this x now. The first thing I'm going to do is subtract 3 from both sides. E to the 4th is just a number. So when I subtract 3, I end up with e to the 4th minus 3 equals 2x. Then to solve for x, I'm going to divide by 2. Now again, if I want the exact answer, e to the 4th minus 3 all over 2 is precise. But they did tell me to round, so I'm going to use my calculator. Okay, I'm going to start by typing in e to the 4th. So second, I'm going to use this e right here because it provides the exponent for me. I'm going to get that number. So e to the 4th. What did I do after I found e to the 4th? Well, I need to subtract 3 from it. So minus 3. And then I'm going to divide that by 2. Now, can you use the fraction button here? Absolutely. Okay, if you use the fraction button and type in the whole value, it will work as long as you're keeping it in the correct notation. So watch here. Notice either way, I get 25.799. So we're going to say this is approximately 25.799. That would be my value of x. Okay, so again, this is the exact, this is the approximate answer. Okay, so I'm going to give you guys two problems to try. I'm going to give you 19 and 20. Number 19 is, whoops, log of 3x minus 2 equals 2. And number 20 is e to the x plus 2 equals 8. So when you are ready to check these two problems, turn the video back on. Go ahead and pause it now. 19, you started by rewriting it as 10 squared equals 3x minus 2. Well, in this case, we can figure out 10 squared. 10 squared is 100. It's precise. So then we can simply add 2 and divide by 3. So when we divide both sides by 3, we end up with x equals 34. And that is precise. Now we can check these by plugging them back in to make sure they work using our calculator. So log of 3 times 34 minus 2. If we were to do that, let me see if I can pull that up. I don't know if I can. Whoops. Wrong calculator. Okay, so if I type in the log of 3 times 34 minus 2 in parentheses, that does equal 2. So I did it right. Okay, so now on number 20, again, hopefully you started by saying the natural log of 8 equals x plus 2. We're going to keep the natural log of 8 for the moment, and we're going to subtract 2 from it. But remember, we're the 8 in the parentheses. So the exact answer would be negative 2 plus the natural log of 8. If you type that in your calculator, that's approximately 0.079. And again, we can check this by plugging it in. We can say is e to the 0.079 plus 2, that 2 is in the exponent, is that 8? Now, notice it's a little off. That's because we rounded. It's very close to 8 though. So because of our rounding error, that's why we don't quite have the exact answer 8, but it is close.